Hello, I'm Janusz and welcome in second part of nuclear power plant inspection with MANDEYE mobile mapping system. In this part, we will concatenate three sessions that we created in part 1. So let's continue. Give me a second, I have to switch again. Okay, so after fighting with PowerPoint, let's start multiple session registration step 3. Okay, let's find our data. Our data is located in this folder and we have 3 sessions. If you remember, we have 3 sessions here. So let's create a project. So we add session to project. So we have to add first session. We have to add second session. And we have to add third session. So we have 3 sessions, you can see, and we can save the project that we don't have to repeat this procedure. Once we have project, we can load sessions. We load sessions and all these 3 subsessions will be loaded into one program, into this program. So it will take exactly the time that all this trajectory of this 4 kilometers survey will be loaded into common frame. Yeah? Okay, so let's wait a little. It's almost done. Okay, second session is loaded. Now the third one, the shortest one. Okay, everything is loaded. You can see 3 trajectories, and the idea is that we will use this software to align it. So what we can do now, we can change that. We can see different colors for different sessions. And first thing is that you can use Gizmo to move it together. Yeah. So let's find some common places that we can align. So if you type only one if only one trajectory is visible, the program is working exactly like second step. So you can make a loop closure like in second step. But if you type 2 of them, then it works like that you can add edge between 2 trajectories. So let's make some experiment. So let's add edge, for example, between 22 and 302. Okay, so we have this edge. We add this edge, and we have to minimize error like before. So let's make 10 centimeters, and then we can align. So we can see that it is working very well, but the Z level is not yet good. So let's make maybe 30 centimeters. Oh, and now it is better aligned. So let's make more iterations, and then let's back and optimize system. Okay, system is optimized. Let's try to find another one, maybe on the top. So we have, let's say, 318 and 19. Okay, so we have some misalignment, very big misalignment. So we add edge, and because it is very big misalignment, let's make 1 meter, and then let's try to register this edge. Let's put 0.1. Okay. This is a training movie, so I will be not so precise. You can always do more iterations, or you can be more effective than me. So let's optimize together. So we have now together. Let's find maybe some edge between the second and third one. Maybe 1 and 342. Oh, there is a very big displacement even in Z elevation. So let's add edge, and let's use Gizmo because error is too big in the beginning. So let's make it like this. Let's put 1, and then ICP. You can align 0.1 to the radius ICP, and we click till the moment that it is not moving anymore. It means it is minimized. So let's optimize our system, and let's find some suspicious or some elements maybe here. So let's add some edge between 290. So let's maybe end and 290. Oh, there is some displacement. So let's add edge. We put 1 meter. Let's put 10 centimeters. And let's optimize our system. Okay, so let's check. Do we have something more to do? Obviously, you can add more points to see. I can see that not so many suspicious elements here. Obviously, this is our, let's say, demo movie, so maybe we can do something more. So maybe we can add edge somewhere here. Maybe 104 and 299. Yeah. Okay, I found very nice place. Okay, so we add edge. We optimize our system, and we optimize everything. You can see that one by one, once you add more and more and more edges, the system is more and more, let's say, beautiful, yeah? Beautifully aligned. Yeah? Okay, so let's make 10 and 300. Okay, we have some small misalignment. Let's add edge, and then let's optimize, and let's optimize everything together, and let's save results and save project, because always we would like to have saved your temporary results, so you will not lose anything. Okay, so suppose that we are happy with the results. Obviously, always you can add more and more edges, but let's make an agreement that we like the result. Okay, so there is nothing. Let's assume that nothing to do more. If yes, then you can click normal distributions transform, that it will refine entire system. It will take long time, but once you click this entity optimization, it will refine model, and then once you save everything, it will be your final model. But our final model will be without NDT, so for the purpose of this training, we just save results again and save the project to be sure, and then we close the software. So now let's export our point cloud that we can do something in Cloud Compare. So we have our second step that we put our decimation bucket to 30 centimeters. It means 1 point per 30 centimeters will be saved. So we load session. This is our session that we are working on all the time. That third step, save to it, we save it, yeah. So everything's supposed to be updated in this file. Okay, we have our session. Okay. Oh, I can see we have some problem with the chimney, so I will simply remove this subset of data. This is 340, I think. Yeah. So if we select subset of the data, we can export less on the chimney. Let's do like this. So you can see that you can export some subset of data. Yeah? Okay, and for the export we have a save all marked scans button. So we have all 0 to, let's say, or maybe all, and the name will be part 1 las. Okay, let's prepare part 2nd. So again, we set our decimation to 033 to be, yeah, and we load session. Our second session, and it is loading. It is loaded, so you can see data. It looks okay. We don't. Chimney also is not good, so we can remove it from the data set. So we can remove it by setting index from the beginning till end, but the beginning will be starting, for example, from the 10th or 11th. Okay, the chimney is okay, is removed, and then we save as a second part. All part 2nd. We save it. And the last one. The last one, the 3rd part. So again, we set to the 30 centimeters. Okay, we load session. The 3rd one, and this is very small, we don't have to remove anything, it's very from icing, so let's save everything, just save as a all part 3. So we have 3 last files downsampled that not all points are saved. You can easily change it, so let's run Cloud Compare and let's put everything together. Okay, so we have our nuclear power plant and we can make some nice things with Cloud Compare. Let's change our color from timestamps to intensity and we change to high contrast to be more beautiful for all our point clouds. Right, sorry. And we have our nuclear power plant. So let's make some very nice things that we can do in Cloud Compare. For example, let's take a look into intersection. Intersection. Oh, nice. Let's take a look what we have here. You can see some very interesting objects in our nuclear power plant. You can play with that by your own. You can always send me email about this data and I can elaborate more. Or if you have any questions, you can always ask me what to do with that. If you are interested in such service, if you have interesting object that you would like to investigate, definitely this project can help you with that. It is very easy to build MANDEYE system, and it is very easy to obtain such results. You can see some very interesting part of this nuclear power plant. Okay, I would like to thank you very much for your patience. I hope you enjoy. Oh, maybe staircase. Oh, you have staircase and so on. You can see some misalignments. I think once you practice with this data, you can obtain much better results than this 30-minute work. Okay, so shortly speaking, thank you very much. Thank you very much for watching this movie, and I hope that you enjoyed. Oh, this is very nice. Okay, see you soon.